Learn how to test a 3-pole contactor. We'll show you the best ways to guarantee correct test results quickly and easily each and every time. You'll be a confident contactor technician in under 5 minutes. Brought to you by the Electro Coach. What's the matter? Pump not pumping? Motor not motoring? Fan not fanning? Maybe it's a bad contactor, and a few simple tests with any multimeter will tell you for sure if the contactor is the problem. We're going to perform these tests with the power on, so be sure to don your personal protective equipment for safety. Here is a schematic of a basic 3-pole contactor in its simplest form. Some contactors have extra contacts, called auxiliary contacts, or an LED indicator light which provides a visual indication that the contactor has been energized. But the ultimate schematic here is all we need to determine if the contactor is good or bad. Okay, it's go time. The contactor consists of a low current, and typically lower voltage coil which operates the contacts when it is energized. These connections are typically identified as A1 and A2. The operating coils can be rated for 12 volts, 24 volts AC or DC, and some other common voltages are 120 volts and even 240 volts AC. When voltage is applied to the coil, a magnetic field is created, and the contactor physically moves internally to close the circuits of the larger contacts. The 3 spring-operated open contacts are capable of conducting a higher current, hence the purpose of a contactor. The small, low-current control voltage can control much larger electrical devices. These contacts are typically labeled as L1, L2, and L3 on the supply voltage side, most times on the top of the contactor, and T1, T2, and T3 on the load side, or the bottom of the contactor. Let's add a 240-volt 3-phase, or 3-pole AC motor. This is going to be our troubleshooting example. 480 volts AC is also popular, but we will use the 240 volts for this contactor analysis. The motor is controlled by a 24 volts AC push-button circuit. When the push-button circuit is activated by a human, the contactor will close and energize the motor. The motor doesn't turn. Mo says the motor is bad, Larry thinks the contactor is bad, and Curly thinks someone forgot to push the start button. Who is right? Every contactor has 2 isolated connections that power the contactor coil. It is typically a different voltage than the device that is being controlled. This voltage is also a lower voltage that is safer for human interaction and compatible with the control components and push buttons. Most times you will see these connections labeled as A1 and A2. The line side is where the higher voltage is provided for the device that is being controlled. This voltage is constant and should always be present on these terminals regardless of whether the contactor is open or closed. And most times these connections are labeled L1, L2, and L3. The load side is where the device is connected and will only have voltage when the contactor has been operated. They are labeled as T1, T2, and T3. And lastly, the ground connection, which is required for electrical safety, can and should be used during troubleshooting as it will provide valuable information for you. Now let's use a digital or analog voltmeter to diagnose the problem. Let's say it's a 240-volt motor that is attached to the contactor. And the motor isn't turning. We will always start by checking voltage on the load side of the contactor. First, we test for voltage between the load side connections. Test for voltage from T1 to T2, then T2 to T3, then T1 to T3. In this example, all voltage readings should be 240 volts. Then test for voltage from each load terminal to ground. T1 to ground, T2 to ground, and T3 to ground. 0 volts for all of these measurements indicates the contactor is not closed. 0 volts on one or more of these readings indicates a problem inside the contactor. If you think you found a problem, you're not done. Move your test leads to the line side and repeat the same measurements. L1 to L2, L1 to L3, and L2 to L3. 240 volts for all three measurements indicates the power upstream is good. 0 volts for any of these three measurements indicates that your problem is occurring prior to the contactor. Now, good voltage readings on the line side and 0 volts on the load side either indicates a bad contactor or a contactor that hasn't been energized by the control circuit. So, let's test to see if the contactor is supposed to be energized. In other words, is it supposed to be closed? The coil terminals are typically labeled A1 and A2. We are going to use 120 volts AC for this example. Test for voltage directly on the contactor coil terminals. If there is 120 volts AC applied to the coil, the contactor should be energized. No voltage, or an incorrect voltage, and your problem is upstream of the contactor, specifically in the control circuit. The coil should be clearly marked so you can see its rated control voltage. Proper voltage on the coil and no output voltage on T1, T2, and T3 indicates an open coil, or a contactor that has mechanically failed. In some larger contactors, the coil and the contacts can be replaced, but in most cases, it makes more sense to replace the entire contactor. One last troubleshooting tip would be to measure from the line side to the load side of each leg while the contactor is energized, for example L1 to T1. This measurement should be 0 volts on each leg while the contactor is closed. Any voltages being measured across a closed contact, even small voltage drops, would indicate arcing or degrading of the internal contacts inside the contactor. This is a great way to find contactors that are degrading and causing intermittent or nuisance problems. This concludes our lesson on contactor troubleshooting. You are now a better contactor technician than you were a few minutes ago. Don't forget to like and subscribe to our channel, and also use the comments below to let us know if the instructions were simple enough. Now go and troubleshoot a contactor. Thanks for learning.